Good afternoon, all. Let us continue the discussion about even and odd signals. In the previous session, we have seen few problems, how to identify the even and odd component of any signal x of t. That was analytical. Okay, that was where you solved the equation. You solved it. Just let me recall. Let me show you the equation. Basically, even and odd signal, the condition is when you replace t by minus t, that is when you take the reflection of the original signal. If the signal remains the same, it is called even signal. If the signal gets a negative sign, if the signal amplitude it changes positive to negative, negative to positive, then it is called odd signal. Okay, this is the basic condition for even and odd. If you decompose a signal, any general signal x of t or x of n for discrete time, if you split the signal, it has got both even and odd component. Sum of all together, both components will give you your original signal back. So in that, when we tried to simplify this, when we tried to analyze this, we got two equations, even and odd. Even, to find the even signal, we will take the original signal x of t, we take the reflection of it, we add both, and we halve the amplitude. If we do this, we will get the even component of the signal. Similarly, for the odd component, we take the original signal, we take its reflection, we subtract both the signals, and we will halve the amplitude of the signal. We will get it as odd part of the signal. Similarly, for discrete time, procedure to be followed will be same, only t is replaced by n, small n. We have seen few problems. I think some one or two problems were given as a assignment work. Hopefully you might have seen in the Google Classroom. This was the question. I hope you have done it. I did not get any answer. No one has sent me the answer. Fine. So let's start today. In the previous session, we have seen few problems which were given in the form of equation. So we solved it. What we did, we took the original signal x of t. Yeah, we took the signal x of t. We replaced t by minus t. That is, we took the reflection of it, and that is equation 2. Original signal is equation 1. Reflected signal is equation 2. Then we added both the signals and divided the amplitude by 2. If you do that, we will get the even part. Similarly, when we subtract equation 1 and 2 and divide the amplitude by 2, we will get the odd part. This is what we have done. Now, we will try to solve a few problems wherein the given signal x of t, it is not any equation, rather it is some kind of signal given to you. Okay, some figure, the drawing is given to you. Then how to find the even and odd parts. Procedure will remain the same. Take the original signal, take the reflection of the signal, add both the signal, and divide it by 2. So how many operations are involved here? You can look into it. One is taking the reflection. This is one operation. Then adding both will be one more operation. Then finally, you halve the amplitude. That is one more operation. 3 operations are involved. This is one way you can solve the problem. Or what you can do, you simply take this equation and expand the equation. The equation is, now it is like this: half of x of t plus x of minus t. This is how it looks now. If you apply this half to both, it will become like this: half of x of t plus half of x of minus t. Most of the textbooks, if you refer, they follow this procedure. What they do, they take the original signal, they divide its amplitude by 2, then they take the reflection of the signal, they divide the amplitude by 2, and finally they add both the signals. So how many operations are there here? This is one operation, then here reflection is one more operation, then dividing is one more operation, finally adding is one more operation. So totally 4 operations are involved. If I go with this original equation, I can maximum I can make 3 operations. So I will prefer this direct equation. If you want, you can solve by this method as well, taking this half, applying to both x of t and x of minus t, and taking the procedure. You can do in both ways. This is the given equation x of t. We need to find even and odd components of the signal x of t. Let's start finding the even part. As the equation says, we need to add x of t and x of minus t. So for that, let's go for reflection. If I reflect the signal x of t, reflection means time reversing. So whatever time you have, observe here, it is 0, 1, 2. All time values, if you see 0, 1, 2, they are positive. So time reversal means make the positive time to negative and negative time to positive. So there is no question of negative time here, only 0, 1, 2. Positive time values are given to you. Put a negative sign before them. 0, minus 1, minus 2. The new time will be negative, left hand side. 0, minus 1, minus 2. Okay. Now, if you see, if I divide this, this is one ramp between 0 to 1. If I take the reflection of it, it will come like this, right? The reflection of this ramp is like this. The range between 0 to 1, you have a ramp like this. One more ramp, the reflection will be between 0 to minus 1. Okay, that's why I have drawn it here, 0 to minus 1, one part. Now, this line, if I reflect on the other side, if I have a line like this, its reflection is like this. Okay. If I have a line like this, its reflection will be like this, right? This part, you can see it here. Okay. So this triangle between 0 to 2, it is now between 0 to minus 2. Just reflect it, flip it. Top amplitude 1 is at time 1. Now the amplitude 1 is at time minus 1. All time 0, 1, 2 have become 0, minus 1, minus 2. So x of t is over, given x of minus t, we have taken the reflection. The next step is we need to add both. How you add them? See here, you don't have any signal, 0, 0 plus some signal. So the same signal will be continued here. Then coming to the right hand side, you have certain signal here and there is no signal here. 0 plus some signal, the same signal is continued. Okay, this is how we add both the signals. What is the amplitude? Amplitude given is between 0 to 1. See, maximum I can get the triangle top, the amplitude is 1. You can see it here, the maximum amplitude is 1. Once I add both the signals, x of t and x of minus t, the next step is 1 by 2 into that. 1 by 2 is outside, okay, it is not related to inside t. So it is the operation performed on dependent variable amplitude. We will not touch the time. We will now work on vertical axis, amplitude. Here, if you observe in the addition, when I added both, the maximum amplitude is 1. If I divide this 1 amplitude by 2, I will get, it is just like 1 into 1 by 2, right? 1 into 1 by 2, you will get 1 by 2. You can see it here. This is your even component, wherein observe the difference between these two. The signal shape remains the same. Two triangles are there. There is one triangle, the same triangle here. One more triangle, the other triangle is same. Just the amplitudes are different. When you add both, amplitude is 1. when you take this half of the amplitude yield is reduced to 1 by 2. This is how we find even part. Similarly, what we will do, we will go for drawing the odd part. So what's the difference? In even component, we added the two signals. In odd component, we will subtract the signals. Let's see. Okay. So if this is on the left hand side, original signal has no amplitude, 0, and here the maximum amplitude is 1. Okay, this triangle is 1. It is just like 0 minus of this 1. 1 is just one number I am giving you, but 1 is not constant. It is like this. From 0, it is increasing up to 1. From 1, it decreases and becomes 0 again. Okay, this shape, it is minus of that, whatever signal you have. So 0 minus of that means some negative signal you will get, negative amplitude signal you will get, 0 minus. That's why if you see, if you take this signal on the negative axis, it will become like this. Okay, positive is like this. It's just like reflection on the horizontal axis. Reflection of this, you can see it in the water. If you see the image of any mountain, it looks like this, right? So that's how it is the negative side. The this part shows the +1 amplitude triangle. This part shows the -1 amplitude triangle, because we have 0 minus of that triangle. So minus. So this is on the left hand side. Similarly, on the right hand side, check it. You have certain triangle with amplitude 1 at the max, and it is changing from 0 to 1 and 1 up to 0. Two slopes are there. Then 0. So it is something like some signal you have, a triangle, minus 0. The same triangle will continue. The same triangle is continued. Okay, this triangle and this triangle is same. Same is continued. So this is what? The subtraction. After that, we should go for 1 by 2, half of the amplitude. So maximum amplitude is, you can observe 1 and -1. 1 positive side, -1 negative side. If I divide the amplitude by 2, both amplitudes will become half, plus half and minus half. Observe, odd part, you have plus half and minus half as the amplitude. The shape of the signal remains the same. See here, both the triangles you can see they are same, and time range between -2 to 2, between -2 to 2, it is same. Only the vertical amplitude 1 minus 1 have changed to half and minus half. So this is how we go for drawing odd component of the signal. I hope you understood this problem. Any doubts you can ask me. We'll move to one more problem. Any doubts? Okay. If you look at this question, do you remember anything? Ma'am, it looks the same, right? Okay, let me recall. Let's go back and let me show you. It looks something like this. No, not this. I think that problem is different. Okay, it is different, I guess. Fine. Okay, this question, it can be asked in some other way. I'll show you during that time. This is the given x of t. This is your second problem in even and odd component sketching. First problem, a simple problem we have seen here. First problem, it was a simple triangle between 0 to 2. This was the signal given. You need to determine and sketch the even and odd parts. So first problem we have seen. Now let's go to the second problem. This is the second problem given. Observe the signal is from -2. It has certain triangle here with amplitude maximum 1. Here please make it 1. Then one more slope here and constant amplitude 1, and it is some infinite signal. Dotted lines indicate it is extending up to infinity. This is the given equation, given signal x of t. For this given signal, we need to find the even and odd parts. So how to go for even and odd parts? I have told you already. We need to follow these two equations. Take the original signal, take its reflection, add both and divide the amplitude by 2 for even. Then take the original signal, take its reflection, subtract both the signals, divide the amplitude by 2 for odd signals. So we will follow the same procedure even for this. Okay. I have taken this original signal x of t. Now let me take its reflection. So for finding the reflection, I will divide the signal into bits. Okay. What I'll do, all together this triangle I will make as one bit, and this one straight line the other bit. The ramp other bit, and this constant line 3 bits. So totally I have divided the total signal into 3 bits. One is a triangle, the other one is a ramp, third one is constant. So let's take the reflection of these three one by one. If I take the reflection of this triangle, the triangle is here. 0, -1, -2. If I take its reflection, it will be like this. 0, +1, +2. Because when I take the reflection, all negative times will become positive. So minus of -2, minus of -1, -0. So the range, earlier it was 0 to -2. New range is between 0 to 2. So this triangle, you can see it. I have drawn it here. So first part is over. First bit. Okay, the triangle reflection we have taken. Now let's move to the second one. The second is a ramp. Something like this. Okay. The reflection of this ramp will be like this. This, just a second. The range of this is between 0 to 1. If I take its reflection, just simply negate the times, -0 and -1. So I will reach here at -1. So this ramp, you can observe it here. Second. Now third value, it is constant. You can observe this third line. Let me draw it. 0, 1, 2, -1, -2, and so on. So if you see, it starts from 1. From 1 onwards, it will continue. So here, somewhere here, it will start. Okay. If I negate all these values, all the time values, 0, -1, -2. So the new values will be -1, -2, and so on the left hand side, extending up to infinity. So that thing from -1 onwards, you can observe it on the left hand side, and it continues up to infinity. So this is how we can take the reflection of this signal. I hope you understood how to take the reflection of this signal. What I have done, For simplification, I have divided your original signal into 3 bits. This one triangle, 1 bit, this ramp, second bit, and this constant line, 3 bits. So total 3 bits. So one by one, for this triangle, the reflection is in this way. Now for this ramp, the reflection is like this. For this constant, which is extending towards the right side, its reflection will be on the left side. So this is how it looks. Any doubts you can ask me. So once we take the reflection, the next step is we need to go for adding. We have to add both the signals, x of t and the reflection of x of t. Okay, if I add, we don't have anything here up to -2. But this is an infinite signal, minus infinity, and this constant 1 amplitude is there until -1, right? So here nothing, 0 plus this constant 1. So answer is constant 1. From this infinite, I should draw this, okay? Up from infinity, it is extending, and up to -2 it will reach, not yet till -1, because here the signal is starting at -2. So I will stop here at -2. Okay. After this, let me take one unit at a time. I hope you understood this, why it is constantly 1. 0 plus 1, you will get 1. From minus infinity, you will get 1. Now let me take this part between -2 to -1. Okay, so this is constant 1, and if you observe, there is a ramp here, and it starts from 0 amplitude and it reaches to the maximum 1. I have split this into again 5 different sub points between 0 to 1, 0, 0.2, 0.4, 0.6, 0.8 and 1. I will split the amplitudes. If I take the first amplitude, here it is 0. 0 plus 1 is 1. Then next point, 0.2. 0.2 plus 1. So plus 1 plus 1 plus 1, it is constant because the second signal is having amplitude 1. So let's see what is the answer. It is 1.2, 1.4, 1.6, 1.8 and 2. You observe amplitudes are 1 to 2, and in steps of 0.2 it is increasing between 1 to 2. So we stopped here. What I will do, I will take one ramp, and from this point 1 up to 2, I will draw a ramp. This indicates all these values. Okay, at every point 2, there is an increase in the amplitude. Now let's move to this unit between -1 and 0. If you observe, the amplitude is decreasing between 1 to 0. 1, 0.8, 0.6, 0.4, 0.2 and 0. It decreases. Here also there is a decrease from 1 to 0, 0.8, 0.6, 0.4, 0.2 and 0. So both are decreasing. Let's start with 1. 1 plus 1. It is 2 only. So I'm here at this point 2. Then 0.8. 0.8 plus 0.8. 1.6. Somewhere here, let me point it. Then 0.6 plus 0.6. 1.2. Mark it on the graph sheet. 0.4 plus 0.4. 0.8. 0.2 plus 0.2, 0.4, 0, 0, 0. So there is a straight line slope with a decrement from 2 up to 0 every 4 values, 4.4 values, the amplitude is decreasing 2 to 0. Now let's move to between 0 to 1. Between 0 to 1, you observe 0 to amplitude 1. If I divide the amplitudes in 5 bits, 0.2, 0.4, 0.6, 0.8 and 1. Here also 0.2, 0.4, 0.6, 0.8 and 1. So let's start with 0. 0 plus 0, 0 only. I am here now. Next 0.2. 0.2 plus 0.2. Somewhere here 0.4. 0.6 plus 0.6. 1.2. Sorry, 0.4 plus 0.4, I guess. 0.8. Okay. Then 0.6 plus 0.6. 1.2. 0.8 plus 0.8. 1.6. 1 plus 1. Maximum 2. So there is a ramp here. Between 0 to 2, the amplitudes are increasing. So please make sure that you're drawing this figure, this particular problem, these signals on the graph sheet. It is better for you. Then let's continue with this. Between 1 to 2, observe here the amplitude is constantly 1. Here it is from 1 up to 0. In decrements of 0.2, it is decreasing. 1, 0.8, 0.6, 0.4, 0.2 and 0. So 1 से 0 तक कम होते आ रहा है. Okay. So let me start with the point. Let's start here. Here I am at 1. 1 plus 1, I am at 2. Next, ये तो amplitude 1 ही है. It's constant. 1 plus 0.8. 1.8. 1 plus 0.6, 1.6 कम हो रहा है amplitude. 1 plus 0.4, 1.4. 1 plus 0.2, 1.2 and 1 plus 0, 1. So again यहाँ पर एक slope आ गया, ramp आ गया with a decreasing amplitude from 2 to 1. Okay, in points it is decreasing. Last amplitude is 1 because 1 minus 0 will be 1. After this, no decrement. After that, let's take between 2 to 3. Between 2 to 3, the amplitude is 1. Observe here, you don't have any amplitude. 1 plus 0 will be 1. 1 plus 0 is not 0. 1 plus 0 is 1. So the same 1 on amplitude, it is continued. Now check further between 3 to 4, amplitude is 1. 1 minus 0 is 1. Then again between 4 to 5, observe 1 plus 0 is 1. Like that it continues. Please make sure that you are drawing these dotted lines on both sides. Then only your answer is correct. This is minus infinity. This is plus infinity. This is the addition of these two signals, x of t and x of minus t. Then how to find the even component? Last procedure. After adding both, you need to divide the amplitude. If you observe, amplitudes are 0, 1, 2. So divide the amplitudes. This will become 2 by 2, 1 by 2, 0 by 2. So see the signal shape, it is same. There is a constant line, ramp, decrement, increment, a ramp, constant. See the shape of this signal and this signal remains the same. Shape of the signals are same. What's the difference? See the amplitudes. 0 by 2 is 0. No change. 1 amplitude has become 1 by 2. Then 2 by 2 means 1. So amplitude 2 has now become 1. So the amplitude gets reduced. जो सिग्नल रेंज 0 to 2 था, अब सिग्नल का रेंज 0 to 1 रहेगा. The shape remains the same, amplitude has changed. Now similarly, let's go for odd part. How to find the odd part? To get the odd part, we should go for subtraction. It's not visible in one line. Okay. Is it now visible? Okay. Fine. So let's go for odd part. To get the odd part, we should subtract original signal and the reflected signal. Original signal is this one, reflected signal is this one. So let's start from the left hand side. We don't have anything here, 0. But if you observe, you have some line here, constant 1 line. So 0 minus 1 is negative. You can observe minus 1. Okay, minus 1 amplitude. So till minus 2, you will get that. After that, let's observe between minus 2 to minus 1. This line and this line. Now, subtract each point by minus 1. See, I'll start with 0. 0. Here it is 1. 0 minus 1 is minus 1. Next, there is an increment of 0.2 here, amplitude. So 0.2 minus constant, amplitude the constant है second signal का. Then next, third point, fourth point, fifth point. 0.2, 0.4, 0.6, 0.8 and up to 1. All should be subtracted by 1. In earlier case, we have added by 1. 0.2 minus 1 will be minus 0.8. Then minus 0.6. Minus 0.4, minus 0.2 and 0. If you observe 1 to 0 ramp है, 0.2 में decrement होते आ रहा है amplitude. If you draw this on the sheet, you can see here, we are here now at minus 1. Minus 1 से 0.2 decrement होते हुए 0 पे आके रुक रहा है. Okay, there is a ramp here from minus 1 to 0 amplitude. This is about the second range. Then coming to this third range, if you observe this and this, let's see, we are now here at 1, here also at 1. 1 minus 1, 0. Then next 0.8, 0.6, 0.4, 0.2 and 0. So 1 and 0 के बीच में decrement हो रहा है. यहाँ पर भी 1 and 0 के बीच decrement हो रहा है. 1 minus 1, 0.8 minus 0.8, 0.6 minus 0.6, 0.4 minus 0.4, 0.2 minus 0.2, 0 minus 0, nothing. All values are 0. That's why if you observe here, when I reach here, I don't have any amplitude here. Because when you subtract those two, it gets cancelled. Then the next range, this. It also is in the same manner. Check 0 और 1 के बीच amplitudes increase हो रहे हैं 0.2 में. 0, 0.2, 0.4, 0.6, 0.8 and 1. यहाँ पर भी same है. 0 और 1 के बीच ramp है. 0.2 में increment हो रहा है. So take the subtraction 0 minus 0, 0.2 minus 0.2, 0.4 minus 0.4, 0.6 minus 0.6, 0.8 minus 0.8, 1 minus 1. All are 0. That's why you can see the same line is continued. 0 amplitude. Then coming to the next, the last one, constant amplitude 1 minus this. सो कांस्टेंट एम्पलीट्यूड है, ये एम्पलीट्यूड 1 और 0 के बीच डिक्रीमेंट होते आ रहा है 0.2 में. So 1 minus 1, first point is 0. Next 1 minus 0.8. Next 1 minus 0.6. 1 minus 0.4. 1 minus 0.2. 1 minus 0. So if you see, observe the amplitudes here: 0, 0.2, 0.4, 0.6, 0.8 and 1. एम्पलीट्यूड 0 to 1 के बीच इंक्रीमेंट हो रहा है 0.2 में. दैट आई कैन शो इट हियर. हम यहाँ पे थे. सो 0, 0.2, 0.4, 0.6, 0.8 and 1. So I will reach here. Okay. After that, observe there is a constant line 1 and we don't have anything. Second signal is 0. 1 minus 0 is 1. So 1 constantly रहेगा. For all this up to infinity, ये पॉजिटिव साइड में 1 है एम्पलीट्यूड, यहाँ पर सभी 0 है क्योंकि सिग्नल 2 पे एंड हो रहा है. 1 माइनस ऑफ एनी वैल्यू 0 is 1 only. The same amplitude is continued. Okay. Please make sure this also you draw like this, minus to plus infinity. So this is how we go for subtraction. This is not the end. Still we need to go for odd part. For finding the odd part, you should change the amplitudes. Here the range is, amplitude range is 1 and minus 1. You should divide the amplitude by half. Say divide it by 2, you will get maximum amplitude plus half and minus half. Plus half and minus half. Signal का shape same है. You observe the signal shape is same. Both signals look the same. Let me just show you here. Okay, observe this